Welcome, everybody. On behalf of the National Catholic Educational Association, thank you for joining us for this professional learning opportunity. My name is Laura MacDonald, and I'm the Vice President of Content at NCEA, and I will be the facilitator for today's webinar. Just a few housekeeping notes as people are joining. We are recording this session today, and we've already started that. If you have questions during the presentation, and you'd like to participate, feel free. We encourage you to use the Q&A window, use it just like a chat, and we will monitor questions and try to answer them in the allotted time. And at the end of the session, I will share a link on the online survey in the chat on instructions on how to receive a certificate of completion for this webinar. Today's speaker is Jacqueline Farley. She holds a bachelor's degree in elementary education, a master's in administration and supervision, and she is in her 15th year of teaching, 13 of those spent in Catholic schools. She brings her knowledge of science and love of STEM into her current pre-K through 8 Catholic school. She teaches at St. Isaac Jogues School, and she encourages her students to look at their surroundings and nature to solve problems. She is always looking for new ways to challenge her students and help them become great thinkers. Jacqueline also works to collaborate with fellow teachers, encouraging the use of STEM activities in the classroom. Before I turn it over to the webinar to Jacqueline, let's begin together as we do all things in prayer. In the name of the Father, the Son, and the Holy Spirit. Blessed are you, O God, creator of the universe, who have made all things good and given the earth for us to cultivate. Grant that we may always use created things gratefully and share your gift with those in need, out of the love of Christ our Lord, who lives and reigns with you forever and ever. Amen. In the name of the Father, the Son, and the Holy Spirit. Jacqueline, thank you for being here today.
Thank you so much, Laura. I'm going to start off with, if you have any questions as I go throughout the presentation, please put them in that Q&A or the chat. And at the end, I'll be putting in some links for you, some resources as I go through the presentation. There'll be a lot of resources and then a actual lesson with the rubric and everything. And I'll go through that as I go through the presentation. All right, so I'm going to be talking about biomimicry, learning from God's creation. This is a fun topic. If you already know what biomimicry is, or you don't, we're going to go over it. So our first point here is I want to look at this quote here. We always look to our students to solve problems that we give them, and our world that we live in currently, we are looking to solve problems that like people every day have. And I just found this quote really, this is from obviously a few years ago. And it says, to rule creation means for the human race not to destroy it, but to perfect it, to transform the world not into a chaos no longer fit for habitation, but into a beautiful abode when everything is respected. So obviously, we always try to bring in our faith into our classroom. And me as a full-time STEM teacher, this is one project that the students really grasp onto. And it's easy, it's fun. And so I hope you enjoy it as we go through. So here's our first question. And if you have an answer, if you want to put it in the chat, that would be great. Also, if you want to add like where you're from, that would be fun as well to just kind of see where everyone's at. So how does God help us solve problems? And you can go from, like you have a problem at work, you have a problem in home, whatever, but to your own way, how do you look to God to help solve problems? I'm going to give you a second. And if you want to add in where you're from, or your answer for that question. I'm just going to add. So one of the biggest things is we look for God is through prayer, and we look to what he has given us around us. We always tell our students we're blessed to have everything, right, that we get. Oh, sorry, the chat's disabled. Okay, so you can put it in the Q&A is where you go. So we're from Mississippi. There we go. All right, New Jersey, that's fun. All right. Yep, prayer seeking counsel. And then we also tell our students, right? We tell them to go to prayer, think about it. So we're going to kind of go into what is biomimicry. And then as we go through this, what is biomimicry, we're going to kind of answer that question through nature. So biomimicry is when engineers or scientists mimic something in nature using the engineering process to design solutions. Scientists and engineers look to nature for inspiration to solve problems. So this is the scientific term. And as we use our faith in our classrooms, we know, right, that God created this for us. So we look to God's creation to solve our problems. And what's amazing is there's scientists out there working with engineers and biologists. They're already working to solve problems by looking to nature. If you teach biomimicry in your class already, you know this, but there's a few things that I'm going to show you as how I use it in my classroom with all the way from my elementary to my middle school classrooms. So one website that is amazing, if you haven't heard of it, is biomimicry.org. And what this is a space that kind of answers that question is how can we look to nature to solve problems from a scientific perspective? We include our faith in that, and we will encourage our students to take a more faith-based look at nature, looking how we're blessed with the trees, the air, animals, plants. So one way that I like to introduce this topic for my students is kind of just show them some photographs, some pictures. I start off with that question. And obviously some of the best answers are the ones that you put in their prayer. We look for peace for him. We sit and reflect, have a moment of, silence and just think about what we are asking God for. So then I kind of show them this picture and I say, what are your takeaways from these two pictures? Have them talk in groups, turn and talk, however you want to manage your classroom. And as you kind of look at these pictures, we're looking at, the shapes of it. Obviously, we can kind of tell that the picture on one side is from a microscope, really zoomed in. And then we look at the other picture, and this man is scaling a glass wall, which is kind of a little like, wow, what is happening there? And so both of those pictures, they're using a technology that was taken from learning from nature. Now, you might already know the answer, but I'll tell you the answer in a little bit. So some innovations that have already happened that people are sometimes not aware of is, we look at airplanes and they were first designed, modeled after birds' wings. We have swimsuits worn by the Olympic athletes that imitate dolphin and shark skin membranes, which we have the Olympics coming up this summer. So you start your year with this and you can kind of look back and look at how those swimsuits are made and travel through water. It's quite amazing, the engineering that actually goes into a swimsuit for the Olympics. Radar and sonar navigation, the medical imaging inspired by echolocation, reusable adhesives inspired by the powerful adhesion abilities of geckos and lizards, super strong and powerful waterproof silk fibers, ice pick for climbers based off of a woodpecker, glow sticks made up light up chemicals. So all of these are these engineers and scientists and biologists looking at nature and we're like, oh, how could I use that to solve a real world problem? Or make something fun like glow sticks, right? So all of these things I'm going to kind of go through and talk about, where do I take this knowledge? How do I incorporate it into my classroom? Because just by looking outside, students can think of solutions that they might have. Sometimes it might be, the newest fashion, or it might be like, I need to make something fun for my friends. So I was at NCA this past year, and one of the at the airport, as I flew in, actually had biomimicry in the airport. So we talked about this when I was presenting in Pittsburgh, and it was quite amazing because you get off the plane, and this was over down by, they have them kind of spread out throughout the airport, and if you don't pay attention, you might just walk by this. So this is Algin Air, and it's actually using algae to clean the air. So they had a little information. You could scan the QR code. You could look it up. So this is one that on that, I'm going to show you a website that actually shows you local industries and companies that are using biomimicry to solve problems. And you could find different around your areas. There's probably a company out there that is using this technology, because this is one of those things that we don't know what our students' jobs are going to be. But definitely something like this is going to be in their future, where they're trying to use nature to solve problems, looking to God's creation. So this website is quite amazing. You can look them up. They're called Alginair, and they have a whole bunch of educational pieces on there, why they did it. And so they're basically cleaning their air, because we know airports and planes are, you know, with all those people, there's tons of things in the air. And this is just one way that a company is trying to solve a real world problem using what we have in our nature. So one way to get students inspired by God's creation is, obviously the easiest one is go outside. No matter what you have, what space you have outside, there's a way to get, you know, to get your students excited. So you could do, if you have elementary students, go on a nature hunt, and make sure, if you are able to, if there's things on the ground already, we don't want to go picking our flowers. But, you know, looking at the way it's shaped, looking at the leaves. So as you have students kind of go outside, kind of prep them and say, look at how it's like coming up from the ground. Look at the shape of the petals. Look at the shape of the leaves. Look at how trees move. Look at the different branches, you know, how they're spread out. Why do you think so? And then have them kind of go outside. Share outdoor experiences. So many students love being outside. And I was able to go to Disney this past spring with my family, and it was the flower and garden show. So they had a whole bunch of different flowers, of like the fragrance and how it helps us calm ourselves, or the different pollinators. They had a pollinator garden. Why are the pollinators important? They had a whole bunch of educational pieces on that. So there's so many ways that students can share their experiences that they have seen outside, even if they go outside and say, like, I love sunflowers. Well, great. How does sunflowers help us? How does sunflowers help animals? So we also have another site, if you are able to Skype with a scientist, if you know what Skype is. It's not Skype anymore, they use Zoom. But we have you can pick your scientist that you would like to Skype with. So in the past, my students have Skyped with a marine biologist that's working with the Navy to study the echolocation use from dolphins and the different noises and what the different noises means. And they try to mimic that when they are trying to be stealthy in the water. So that was really interesting to hear her viewpoint on it, and how she uses the animals' sounds and their echolocation use and transfer that knowledge and give it to the Navy, and they can use it in their way. AskNature.org, we are going to be researching on that one in a second here. And then obviously biomimicry.org. So once they're outside, if you have a camera, if your students are one-to-one with iPads, we are very blessed in that way. We do have iPads for our students. So what I have them do is kind of go out, take pictures. They come back in for my little ones and kind of do a reflection on what they saw. Why'd they take that picture? have them draw pictures of what they saw. If you don't have an iPad or whatever, you can, ask students if you have a camera that you can use from your school, and then plug it in when you guys go back in and kind of go through all those different things that you saw outside. Obviously, the students here were kind of focused on our plants. We did see a few animals scurrying about, but especially our picture of our vines going up the side of our building. Students found that to be really interesting. And then the other picture here, the student was kind of zooming into this flower and the plant here to kind of see how it's spread out. And I said, well, what would you design based off of this plant? And they're like, I would make a dress. I said, okay, that would be great. So, and then you kind of guide the students in that sense of, like, what problems, real world problems, could these solve? Looking at the vines traveling up, what does that mimic that we make today? Ropes? How does it stay on the wall? Looking at that. So those are some fun ways that you can get students, and everybody usually has some kind of outside area. If you don't have an outside area, maybe plan a field trip to your local arboretum or park, something like that. That would be a lot of fun for your students. And you can encourage them, if they have like a camera or something like that, to bring it. We obviously also look to our saints. We have our saints of nature, Saint Francis Assisi, and these saints are obviously, there's different things behind it. We know that Saint Francis, we always look to him for our animals, our nature outside. And then Saint Kateri, St. Paul. We have, if you kind of go into Google, you can go down a whole way. And I actually have outside my room Saints of STEM, which is really also a lot of fun. If you want to throw that in there, there's, you have the Saint of Scientists, and then Carlo Acutis, we have the technology. So don't forget about your saints whenever you're doing a project. I think that is always a fun piece that you can add into your research as well. All right, so our elementary classroom, if you're an elementary teacher, even some of this kind of applies to our middle school students. And we usually look to the standards, always looking to our standards. If your diocese has specific science standards, they usually, most of them are trying to incorporate that NGSS standards with our science and the engineering piece. So if you look at God's creation and we're studying birds, or you're studying plants or animals, make sure you always tie that piece in, tie our faith in, tie that God created this for us to study and learn from. So if we have just different materials and you say, how would you pick up these pieces? And I usually don't introduce that. This is kind of the introduction topic. I usually don't mention birds because I don't want the students to, I'm kind of giving them the answer of what we're trying to mimic here. So I give them materials and we talk about how can we pick up these items without using our hands. Your hand can move the item, but you cannot touch the items with your hands. And then we talk about what things in nature pick things up. And eventually they do kind of come to that solution that, oh, birds use their beak. Some animals use claws to open things, but that's their hands. So then we talk about, well, how animals use their mouth, how animals use their tail, maybe to grab things instead of their hands. And then we talk about how animals solve problems that they have. Is there any problems that animals solve that people have as well? And we talk about, well, how do they get their food? Animals just can't go to the grocery store. And then how would animals solve the problem that, people would have? And then we use the engineering process to solve our solution. And I'm going to kind of go through our, before we do that, I have a great opportunity this past week. I went last week. It was called aircampusa.org. And it is a teacher camp. And what they do is they talk about flight and biomimicry and how our earliest Wright brothers, Leonardo da Vinci, studied birds to create their flying machines. Obviously, Leonardo da Vinci was not successful, but the Wright brothers studied Leonardo da Vinci, realized that he looked to birds, and that's how the Wright brothers got their first flying machine, because they realized they needed that give and take of the flight of birds. Quite amazing. So if you are looking for a wonderful PD, it happens in the summer. You do have to sign up. It's called Air Camp. And you get to go, I actually got to fly a plane. So that's always fun. If you are afraid of heights, they make it very wonderful. But if you reach out to your local falconry, and that is a thing, if you are aware of it, and you have to make sure that not all of them will allow the birds to fly to the student's arms. But what amazing is that they will bring in birds, birds of prey, falcons, and other birds, and they will talk about their flight. This is where a great opportunity for the students to kind of study birds themselves and look at how do these amazing creatures fly, and how can we make a flying machine based off of these amazing creatures. And I do have a video, so hopefully it will go for you, of watching this bird fly. So I'm going to play that. Turn our mute off there. So you can see the bird flying. We did slow motion, so we have that wonderful sound there. And you can see how the bird's wings kind of pull back for it to land. That's exactly what the Wright brothers were looking at to see and to create and finish their flying machine. Another wonderful way is that you can look at pollinators. That obviously is a big problem that we're facing. Is, we don't have grasslands for our bees to find pollen. Our butterflies, all those wonderful creatures that God gave us to make our rotation, our circle of life work. So one thing that we talk about is how farmers and people are trying to mimic pollination because they are not getting the pollinators they need. And one fun way that you can do that is, this is with my elementary, you can always bump this up to middle school. And it's really amazing, the students, when you start talking about your faith and what God has given us and telling them that we are so blessed to have all these creatures, the answers and the solutions that they come up with is quite amazing. So this was a fun, you can always get this on Amazon or whatever, but you get UV powder and you get a UV flashlight. And you start with the lights on. Obviously, they have to build a pollinator, so we study pollinators. We look at different pollinators, animals, bugs, plants, that kind of thing. How do they get their pollen? How do they reproduce? Then they have to mimic that and build something using the engineering process. And I put the UV powder on these flowers, and then they have to bring the pollen to one flower to the other. Then we turn the lights off and we use our UV flashlight, and we get to see if they were successful. If they weren't successful, they went back to the drawing board and redesigned using the engineering process. So it's a fun activity that you can do as you kind of get through this, the biomimicry. You can almost use it as a whole unit and incorporate all these pieces into there. So our middle school students, as we travel up, we have our biomimicry activity. And obviously, you can also do this if your students are, if you are doing the engineering process with them and they are becoming a little more proficient, you could definitely do this. I've done it with my 3rd and 4th graders because we are blessed again to have iPads. And if you are not familiar with Tinkercad, that is a 3D design piece online. It's an app, or you could use the web-based program. It's great because you can make your students, and it's a safe account. You can create it, it's all free. And they have a whole bunch of other things on there. So that's also a great resource for you to look up. So our biomimicry activity, students will pick an animal or plant and identify the structure that scientists could study to model an everyday item to solve a problem. So below I have some solutions that students came up with. You can kind of see we have some similar structures of an animal. Others go for creating a problem or solving a problem of warmth or cool. Here we created a tire based off of an animal structure, paw structure, and I'll kind of talk about that one in a second. So is there a way that animal or scientists or biologists can look at animals and solve problems? So one that we do a lot is that we obviously use that engineering piece, and then they would construct a prototype with materials or 3D parts. Now, if you don't have a 3D printer, then you don't need to have a 3D printer to use this program. Students can design this and have it on there. They can take a screenshot, they can add it to their slideshow, that kind of thing. But it's just a different tool for you to use within your classroom. Obviously, some students, they still like to draw it out and then design with classroom materials, and that is perfectly fine as well. So we are Ask Nature, the biological strategies, we're gonna kind of look through that. And that one is already problems that they're looking at different creatures, animals, fungus and things like that. And then scientists are actually studying those, create those parts of it and looking at problems that they could solve using those animal solutions, plant solutions that they're already doing. So I obviously always include a rubric with my students, and I'll be sharing this with you guys. We'll send it in a chat. It's a link to the rubric here, and then our requirements. Okay, so for our middle school ones, and again, you could always adjust this for your younger students as you're going through. But my students know that they're always given like the requirements, they're always given a rubric to kind of go through and kind of solve that problem. So the main things that they're looking at is they are picking their animal or plant and the structure, why they want to study it. They give a description of the structure. So if they're looking at the wing of a bird, then they have to understand and describe how it's benefiting people. We have the description of what scientists might use the structure for. So if they're looking at a bird's wing, they're going to use that structure to solve the problem of flight. And then we have the picture or what they're drawn and, how does it benefit people? They need to make sure. And that's sometimes a little challenge for students to do, is to identify how people can actually benefit from the structure. So if we look at flight, think about how flight has changed over the last few years even, and breaking the sound barrier, traveling into space. Those are things that all started back by people studying birds. So that's one thing to kind of, you get the students really thinking about it. And, how did we get to space travel when just think about how many years ago the Wright brothers were trying to fly their plane. So obviously, I always try to include in our design process, the virtues are such a big thing in the classroom, especially in mine. I see all students pre-K to 8, so I have to set the expectations when they come into my room. These are, you need to show virtuous behavior. And I'll use those exact words. That's not virtuous behavior. And so I enjoy these posters. I have them up there from Open Light Media. They were at NCA, and they are amazing resources online. So if you haven't checked that out, they have a lot of great resources, free resources, paid resources, and a lot of schools are already starting to use them, but the education and virtue are great resources that you can use to have in your classroom. Now, the reason I'm going through this is because our engineering design process that I use, I kind of go through and we talk about the different virtues that I should see as you go through this process with your group or individually. So as we're obviously our create, we have our self-control and our test persistence, and improve. Are we taking everybody's ideas into play? Are we respecting materials? Are we respecting our classmates? And are we kind of going through, are we showing our patience? So obviously, our students definitely know our virtues, even as I'm including them into this engineering process, which is also a big part. So let's go ahead and take a peek at our biological strategies, our Ask Nature. So this website has amazing resources on it for educators and well as your students. So I'm going to kind of talk about our student resources first. And when you're looking at your strategies here, you'll go to search strategies, and then you have a whole bunch of different resources that that students can choose from. And this is kind of where I kind of send my students, I kind of have them try to think of a problem that they want to solve, or think of a problem. Oh, they are recording it, so they will release the webinar for you guys later. So in case I know it's a lot of information and a lot of great resources, so I don't want you to miss any of them. So don't worry about that. So our students that kind of need a little more guidance, you can kind of walk them through this and maybe give them a specific topic. Or we say we're just focused on animals, or we're just focused on plants, because this obviously can get overwhelming, and you know your students, you know what they can do. For my younger students, I usually give them specific links or specific parts that students can try, okay, such as animals or plants. And then for my, for specific grade levels, around second grade, you're really focusing on the plants and the plant process and how does that work, photosynthesis, all that kind of stuff. So that maybe you could bring up some of these and look at what scientists are actually studying for our plants and not our animals, for adaptations, for getting into our, like fourth, fifth grade, those around there. Then you kind of go to our animals, look at our bumps on our polar bears. They increase grip. Well, we know that, right, as adults, but maybe your kids don't realize that, most of their surfaces that they travel on are probably a little slippery. And so this is how scientists are using the structure of the polar bear to create different things to help people walk on ice or walk on slippery situations. And so over on the side, we have the contents, introduction, strategies, the potential, and references. The one that I tell my students to look to is the potential. The potential talks about, obviously we know, oh, what's potential? This is the potential for it to grow into an actual solution. How are scientists already studying this topic? And what can we look to nature? This is right here, right? The potential. Amazing. I was at NCA in Texas, and this Sharklet Technologies was actually on the door outside at NCA. I had a few during my presentation, I called it out because a lot of people went back down and they're like, I saw it. So on the door frame, our shark here has a antibacterial film on his skin. And so what this Sharklet technology did is take that technology and transfer it into a device that goes on door handles. Pretty amazing. And with that, it causes no bacteria to grow. So if you're pushing those door handles, right, that's one of the dirtiest surfaces everywhere that we go. And that actually you have one side here with the Sharklet technology. That's kind of what I showed you earlier, if you remember that picture. And that is what they mimicked the shark skin. Now, this is also a big thing that students a lot think that, like, do I have to get a shark skin, like the actual shark skin, and put it on the surface? No, we're mimicking. So I sometimes have to describe the difference between mimic and we're not hurting sharks. Okay, so we want to make sure that that's one thing that students sometimes struggle with. You think it's a obvious thing that as we're talking about God's creation, we don't want to hurt God's creation. But sometimes they often get confused and are like, well, why are we going to have to hurt sharks? No, we're not hurting sharks. We're mimicking. So one side shows the shark scales that have that antibacterial quality. And the other side shows the sharklet, the synthetic surface that they have created that they put on the door handles. So you can see that on the picture here. Pretty amazing that all of this is coming from nature. So this is one that I usually take and I give this example for my students because I like to show them this picture of like how we're truly, scientists and engineers are truly mimicking the skin of the shark and not using the actual skin of the shark, if that makes sense. So when our students kind of go through, I have them, they can make a poster. My little ones, I usually have them make a poster and kind of talk about the actual shark or the actual what they found and things like that because it, it's easier for them to kind of work in a small group. My middle school students, I have them work on this individually. So if you're looking for an individual project, I usually do this in January when they come back and they're like, okay, we all need to just sit down. So we have our slideshows here. So here's some examples of our slides that some of my students did. Dolphin fin motor, and they use Tinkercad to kind of create a motor, but, and that's the thing too, like they're not current scientists. So I said, your prototype is a prototype. And we know that multiple prototypes have come from a good finding. If we look at the Wright brothers, I'm going to go back to them. They had multiple prototypes before they made the actual plane. So those are always things that I talk to students about. Yours might look like a thing that's already out there, but if you explain how you're using that technology of the dolphin fin and talking about how we look to that dolphin to solve problems, then, that's okay. We're not looking to, I'm not sending you out into the world and sending you to scientists to solve this problem right now. So this is also a good way for your students to kind of struggle and kind of problem solve. A lot of students get frustrated if they can't come up with a nice design, and that is a skill that they also need to understand is that I might need to make multiple designs. I might need to start over, and that's okay as well. Persistence, the virtue of persistence. All right, and then my students love to use the Tinkercad. And this is, again, is if you have a 3D printer, even if you don't, you can still use Tinkercad. It is free for teachers, and you sign up and you can add your students in. They can have their own account. And what's amazing is you get their designs right on your teacher account. You can make different classes. So I have all the way from my kinders have used Tinkercad. And there's lots of tutorials about there if you, want an extra summer project to do. So this is based off of our gecko here. And the student had it where it would shoot out. This goes on your wrist. You can kind of see a wrist kind of circle there. And it would shoot out a sticky, almost like a tongue-like object, and it would pick up garbage. That was his idea, which, I mean, that's a very simple idea, but it's a true student idea. Like, what's the problem? We have lots of litter on the ground. How do I solve that? By looking to God's creation. Well, animals use their tongue to pick things up. I could create something that has a sticky thing. It sticks it, I pick it up, and then I release it. Now, the gecko, how he used it is the foot of the gecko. And I'm going to talk about that in a second because that ties back to that first original picture that we had. Also, if you are interested, they have a youth design challenge for your middle school and high school students. So if you have middle or high school students, this is a great opportunity for your students to have, you know, you obviously as their teacher have to host, and you can get the parents and all that kind of stuff. But it's a great experience for students. Now, if we go into your questioning, so I started off with that question of, you know, how do we solve problems, right? And asking God, right? Prayer, all that kind of stuff. But can we look to God's creation? Yes. So then I kind of tie in these questions. Where do you think Velcro came from? What animals can climb walls? How could we mimic this behavior? And why would we mimic this behavior, right? So then students kind of discuss and that kind of thing. And then I show them pictures of the burrs and that kind of thing. And that is where Velcro came from. Okay. And so students are all kind of like, whoa, what? Mind's blown. This is where Velcro came from. It came from a plant. Yes, that's exactly where it came from. Someone got the idea, scientists walking through, the burrs got stuck, and that's where we have Velcro. Now, if we, another fun way, I love to have different pictures and slides up of my students. Obviously, we know our students need a visual now. They're all on their phones. They're all on that. So I love showing pictures and having them try to figure out what it is. So this picture is another one that I will start with as we kind of are going through the project and have them kind of guess what it is. And so obviously they are like, well, that is zoomed in of something. Is it fur? Is it cat fur? What is it? And then I kind of show them this picture, and then they start seeing kind of the foot's kind of shape out. So then they're like, well, it's a paw of something. And then I zoom out even more and we get our gecko. So obviously those last few pictures, this is extremely zoomed in. Then we have a zoom out picture of our paw here, or our the foot of our gecko. And it's kind of amazing. You can still see those pieces that were extremely zoomed in on our gecko. And then we have this out. So if you have a gecko at school or in your science lab, this would be great to bring him in and show the students. And we have our parts of our gecko here and on his foot. So they actually are able to stick on a wall, okay, or glass, and then actually release their foot. So that is what scientists were studying. So if we think about that picture that we saw at the beginning where they were climbing the wall, we have in this type of technology has been in space, which is pretty fun. Obviously, Stanford did a study. They tested it out NASA. Then they sent it up to the space station. They needed something that our scientists in space could push on and release, obviously, because what's the problem in space? Things float up. So they looked at our geckos here. They looked at them because, well, they can stick to a surface, but they also don't stick there forever. And how does that work? So they're little fibers. They have a detached state and an attachment state. And even this is fun even to show to our little ones, because these guys are cute and they love little animals. And they will be intrigued because, one, we have an astronaut in space, right? And that is something too. And what is fun to see is the students actually start pushing their hands onto their desk and lifting them up. And you know, you have to kind of pay attention, but you'll see students after we talk about this, they'll kind of push their hands and push them on their desk and be like, well, mine don't do that, right? Why is that? So then we look at our fingerprints and say, well, our fingers and our hands are not meant to do that. But these guys have different states that they can put their feet in to climb a wall. So they've actually mimicked this using the technology and have created and sent this out into space. We also then see our people flying on and walking on the walls, okay? And this is where our future careers come in for our students. Our students have an endless amount, right? Biomimicry engineering, where bioengineers, right? Our biologists and our engineers are collaborating, working together. So I always talk about this with my students, that I don't know what your jobs will be, but think about the jobs that are here today and that weren't here like many years ago. Think about our earliest engineers, our Wright brothers, Leonardo da Vinci, and then look at what we use today that we have. And so think about what can happen in the future if we keep studying God's creation to look for answers. One amazing thing that I'm going to show you is I have a few sites that we're going to look at. Let me pull them up. So our Ask Nature, we have our biological strategies at the top here. So when I click on that, we get our search strategies. And so this is where you can type in if you're looking for a certain animal. And obviously, you know, they want to pick like, oh, panda, you know, elephant, dolphin. And sometimes there's not an answer for them. Okay. So we looked at the polar bear already. And so here's a whole bunch, and there's our clip right here that I showed you earlier. And so we have, if I scroll down, here is our potential that I talked about. So this is what researchers are currently studying to solve problems. Now, again, if you feel like your students, if this is too much for them, obviously my middle schoolers, they were able to handle it. My fourth graders needed some guidance. And so we kind of went through it together. So I shared the link. We use Google Classroom. So whatever you use, even if you go through it as a class and you pick one animal in elementary and you study that animal and you go through it and talk about how we solve problems looking to nature, God's creation. That's also a great way. Then we have up here, we have for educators. This is a great resource as well. There is so many lessons out there for you. So it talks about why we should teach it. And we obviously add that extra little piece in there because it's our faith, right? So we have down here, and it will show you the grade levels that are accessible for you. And it gives you resources. So here's that Velcro. This is a fun one. The kids love doing this. Even it has pre-K, right? So that's so much fun. Now this, at the top, it says innovations, okay? This is where you can search for current solutions that have been solved, okay? So right here, I'm going to click on, so this has so it says sustainability, cities and communities, software and IT, safety. So this, I'm going to click on over here. We have Myocycle. I'm sure I'm saying it wrong, but they are actually based in my area, in the Chicago area. I'm from around there. And they have created this company that uses fungus to break down toxic petrochemicals and produce sturdy, lightweight products. Pretty amazing. So they got the Ray of Hope prize from biomimicry.org. They picked different companies and things in the community, people in the community that are trying to make things better using nature. So this talks about this. Obviously, you can kind of bring this up. Also, I reached out to this company, and because they didn't pop up on here until like towards the end of the year. And so I reached out to this company, and then we already set up a date for them to come out and talk to my students through Zoom or personally come out and talk about how their company works and how they use biomimicry to solve a problem, which is amazing. So I'm sure that if you find a company or a topic that you think that you want to talk to your students about, that there's a lot of these companies out here that they want to get the word out about how their company works. And so they're willing to work with educators and students to have that. Our next part that I'm going to show you is my student projects. So this was great. She had created a slideshow, and this, I'm leaving it kind of like this so you can kind of see it's not a lot of slides, and that's what I tell students. You're going to have some information on there. I mean, she could have kind of broke it up a little bit, but to not have a lot of reading on one slide, but that is okay. I just want them, they have the resources on there. So they were focused on the harbor seal, specifically the whiskers of the harbor seal. Now, this is pretty amazing what she thought of. To the problem that she thought of was for someone to sense when things are in front of them. So the whiskers of our harbor seal are used to track prey and movement. So if we look at our scientists are going to create a device for blind people, which that's pretty cool. So she have how would this benefit people? So we have it here. Obviously, cute pictures are always a win. And then we have our prototype that she designed. So she used Tinkercad. Obviously, this I wouldn't be able to 3D print the big whole piece. I am blessed to have a 3D printer, but it is not that big. So she just went with this design and then built a prototype using classroom materials like cardboard and things like that to show people what she actually would create. So on the top here, you have her, what would go on their arm. And then this was the stick for the blind, And at the bottom was sensors that mimic the vibration that a seal would feel. And it would send notifications to the person that something is approaching or something's in front of them. And it could, now, is this something that could eventually actually be? Maybe. Is this something that maybe exists? We would have to do a little more research to see, but I know there are more advanced technologies that are helping people. But this is something too, like you could always do an extension for those students that need more enrichment. So I would send her on a task because obviously she is a student that works hard and gets her stuff done, right? So she would probably take this the next step further, and I would maybe have her add a slide of like what other materials are out there that kind of are already like this, and can you enhance yours by using their technology? So the overall product here of the student is well done. And then she has all her research and she found all this. So she looked specifically for the harbor seal. You can, so I have them use like the Britannica or something like that to actually research the animal or the plant. And then they use the Ask Nature to kind of see if this topic is already being researched and use that information from that site. All right, and so then we get into our, like I said, our future careers and things like that. Now, one thing I have here with some seals, which is fun. So my sister worked at Hogle Zoo in Utah for a while. She is back here in Illinois. And she works for the DuPage or the Cook County Forest Preserve. So we still get to be invited and see some animals and everything like that, but it's not as cool as working in a zoo. And I told her that. So she was able to get us some behind the scenes here at the Hogle Zoo. And so I got to help train a seal and stuff like that. So sometimes I'll show this to my students to kind of get them excited about nature, get them excited about animals and plants. And now, I mean, most kids love learning about animals and plants. I feel like they kind of lean towards more animals than plants. So, if you have a garden or something like that, you could kind of take your students out there and get them excited about plants. But I like always sharing my experiences with my students so they can kind of, know that I'm excited about this topic, just like they should be excited about this topic as well. All right. And so now we have this last question. How does God help us solve problems? And we have all these answers to our solution, right? We have flight. One student talked about butterflies. If you see the blue butterfly over here, they actually create a chemical, it's a safe chemical to create that color of blue. So scientists are actually studying this butterfly, not by hurting it, but by setting the butterfly to create a chemicalless color. So it would be safer for the environment because certain colors are actually, to make certain colors actually has a lot of chemicals involved. So those are some fun ways that you can, your students can always go farther with this topic. And you could kind of do a whole unit, like I said, of this topic. It's quite amazing of what actually encompasses biomimicry. There's so many pieces that tie into it. And there's a lot more resources out there than we think. So I hope that you're able to check out some of those resources. So here's some more. I have some wonderful books. Nature Did It First. Mimic Makers is a wonderful book as well. AskNature.org, there's Biomimicry. I have The Story of Inventions. I didn't have that on my slide, but if you even have them look at different inventors, most engineers and inventors start out by being outside, which is quite amazing. Obviously, there's some that have nothing to do with nature, but most start with nature. So that's always a fun task, is to kind of look at different inventions. And then I have a Jumper. If you haven't heard of this book, it's about a little spider and how he uses his web and how he jumps. So we can look at, how do spiders jump so far and they're such small little creatures? Can we mimic that spring-like possibility in something to help us move along a little faster, or jump across something like that? So even if something can't come to be, who knows what our students will do, in the future, especially our little ones. Their world's going to be a lot different in 10 years than what we have now. And this topic, including our faith into it, is quite amazing. Obviously those websites, again, the Biomimicry, there's the Youth Design Challenge and Biomimicry resources. I like using the Ask Nature for my students. The biomimicry.org has resources for teachers as well on there. If you go up to the top and look at educators, but sometimes all that information can be a little much for our elementary students. If you send your students to there, it could definitely help them out with that. But the Ask Nature is a safe site that I like using. There's not really much else where they can go on there. It's made for students to research. It's made for people to research. That's why I like using that website instead of Google as a site, which they think is a resource. Just Googling things. This is a specific site that the students can go on to and travel to for safe ways. I'm also, you can find me on Instagram at Positively Teacher. So I talk about other ways to incorporate religion into STEM and science. There is, if you're looking for a fun STEM activity, Fishers of Men story is amazing. Make some fishing poles. We have a lot of resources at my school, so I'm very blessed in that way. But also I will usually try to talk about some great ways to include our faith into STEM pieces. All right, does anybody have any other questions? You can put this. Yeah, this definitely, I see the one question about understand God's design of us. That would be, a great way to, even if you're starting with that and then tie that into this topic, just how we solve problems as ourselves and what tools God gives us to solve problems, is a great way to start that topic. And sometimes I ask that question of, how does God help us solve problems? And a lot of students think about, just themselves and say, okay, well, I pray, God gives me gifts, I'm good at sports. What else can I do to help others? And then we say, okay, well, let's look at nature. And how does nature help us solve problems? And so kind of sometimes like, woo, we get a little like mind blown there of like, whoa, I can do that. And then let's see, I don't want to miss any others. I don't think we have any other questions here.
New one just popped up, and it's about finding this recording.
Oh, okay.
Yeah, so first of all, I'll answer that. But first of all, I bet your students really look forward to Miss Farley's STEM class at school. What a treat. I'm sure all of the teachers right now are very jealous that you're not at their school. Thank you for being with us here today, Jacqueline. And thank you to all of you for attending this webinar. NCEA continuously strives to improve the quality of our services for our members based on your feedback. So I've added the link to our feedback form in the chat box. So if you click on that, you can complete that form and give us that valuable feedback. You also can get a certificate of attendance by including your email and name at the end of the survey, and you will get an automated email with a certificate. If you don't get that, please check your spam box. Sometimes NCEA members happen to have their mail in the spam, so check that as well. To find today's recording, it will be added very soon onto the ncea.org website. If you click on PD, the professional development page, and scroll down below our upcoming webinars, you will find on-demand resources. And that's where all of our, if you missed any of them, you can find them there or at our YouTube page. Do we have any more questions? Lots of thank yous and lots of great information. So thank you so much, Jacqueline.
Thank you. I'm gonna well, they'll see my chat, so I'm gonna bump over here and show you guys. I want to add in the link for the resources. Also,
Perfect.
if you I'm going to put my email in there if you have any questions about it. So in the past, I've had a few teachers ask me about the thing. So I'm going to share with you, you'll see the link here, and that will have a link for the topic, the example and the rubric, and the student example as well. So if you have trouble, you can always email me that. And then if you have questions, in the past, I've shared other things with teachers after the presentations or other student examples. So if you have any questions, please don't hesitate to reach out.
Wow, thank you so much. That's great information and sharing of those resources. You know, the best, I always say the best resources we have is each other. So thank you very much. Everybody have a great day.
Thank you.